In the previous video lesson of vector addition, we learned special case 1, and that is also known as the case of maximum resultant. And this time we are going to talk about the case 2. In maximum resultant, we simply learned that when two vectors are acting into the same direction, then that time the addition of those two vectors will give us the maximum output, maximum resultant, and the resultant's direction will be the direction of the first or second vector, right? And now we're going to talk about when two vectors are acting in opposite direction. All right, so for a while, let's say I have a vector, let's say vector, again let me say this is vector A, and I have another vector B. All right, this is vector B, but they are opposite to each other, so it means angle between them is 180. all right, that means opposite. One is acting towards this while another is acting towards this, so the angle between them is 180 degrees. So when you add this properly, then it will be something like, this will almost finish this much portion, so we'll be left with this much portion only. So what we get, that the resultant is getting shorter, but I will show you by the formula method. What we learned, that the resultant is always p square plus q square plus 2pq times the cosine of the angle between p and q. Here cosine of the angle, it means angle between this vector A and vector B. all right, this is all inside the root. So p is here A, all right, so it's a square. Q is here b square, all right, plus 2 here. P and q are the magnitude of vector P and magnitude of vector Q. It means magnitude of vector A, all right, this will be working as a P and this will be working as a Q. So this is simply A, all right, and this is B. And what is the angle between them? Angle is cosine of 180 degree, and cosine of 180 degree, everybody know that is -1. all right, so a square plus b square minus 2ab. all right, and the same thing can also be written like this. Okay, so actually I have already mentioned, I think square of this is written also like this. all right, so now it is simply vector A square, vector A minus vector B whole square. all right, all are inside the root. So now I can cancel this square root with this square, and finally our resultant is getting vector A minus vector B. So this is the resultant. all right, and this is again magnitude. Oh my god, I always make mistake. all right, so magnitude of the addition of these two vector A and B will be the difference between these two vectors, all right, because both are acting to the same line but in opposite direction. all right, so we whatever will be the bigger vector, it will be towards that. So here for this instant, if you see, the vector A was bigger, all right, vector A was bigger and vector B was smaller, so it will be like up to here. So we'll get the resultant will be less than both of them, all right, less than both of them, but into the direction of this bigger vector A. all right, and let me find out first direction also. all right, I should show you the direction also. This is B is going to show you some degree that is going to make with the first vector A. all right, so B, generally we write tan inverse q sine theta divided by P plus q cosine of theta. This formula I'm taking from the triangle law of vector addition, or you say paragon law of vector addition, and according to this it's going to be now tan inverse q is here our B, sine is now 180 degree divided by P is A, and again B cosine of 180 degree. all right, and my dear friend, sine 180 degree is 0, so overall we're going to get tan inverse 0. That's finally 0 degree. all right, so angle is again 0 degree, so the resultant is going to make 0 degree. all right, so the resultant will be either in this direction or in this direction, but depends on which is more powerful. I mean, which one is more stronger vector. If A is stronger, then the resultant will be into the direction of A, and if B is stronger, I mean B here I made it shorter, but if it has been bigger, then it will be in the direction of B. And this is only the case where we get the minimum resultant. all right, the resultant will be minimum when theta is 180 degree, or we say when when two vectors are acting directly opposite to each other. This is the case of minimum. All right, let me give you some example in real life. Let's say as I had given you in the previous video, let's say you are here. All right, you're running very fast in this direction. All right, but while running in this direction, your friend is just holding your collar and trying to push you back. That time, let's say you are running with 30 meter per second with this speed, and your friend is pushing you by 50 meter per second. Right, so what is going to happen now here? See, the miracle is going to happen. You're gonna move towards this direction by 20 meter per second. All right, as I told you, let's say this is here, you know, which one is stronger? A is stronger here, right? So A is here 50 meter per second. This is working as A, and vector B, that's your vector, that's working as 30 meter per second. All right, so the resultant magnitude of the resultant will be vector A minus vector B. All right, let's forget for a while the symbols. So 50 minus 30, that's going to be 20. All right, 20 meter per second. So your speed will be now that time 20 meter per second, but what will be the direction again? So to find out the direction, as I told you, that's going to be 0 direction and will be into the side of a bigger vector. Here bigger vector is A. All right, so this is bigger vector, means 50 meter per second. So you're gonna move at that time by 20 meter per second towards the direction of your friend who is pulling back your collar. Such a bad friend. All right, so this is a very simple example. Or one more example, let me tell you. Like car example I used to give, you know. Let's say a car is moving. Let's say this car is moving with let's say 2000 Newton in this direction towards east. All right, and a big, again, monster truck. All right, both are into the same road but acting just opposite to each other. Right, is with 10,000 Newton. Oh my god, with 10,000 Newton it is moving in opposite direction. It's moving in west. All right, but some stupid guys connected both of them with a chain. All right, so, and both of them were started together simultaneously. Both of them were started. So this is trying to move towards east, but this is trying to move towards west. But since this is 10,000 Newton, very stronger than this 2,000 Newton, ultimately this truck will pull this car towards west with of 8,000 Newton, because the magnitude, as I told you, is just difference, you know, A minus B. All right, so it's 10,000 minus 2,000. So this is the practical application of this vector addition in special cases, and this is the case of minimum resultant. This is only the case where you'll get the minimum output. So I hope you learned this, and in the further video we will learn more and more about the vectors. All right, see you there. Bye bye, and please don't forget to subscribe the channel.